Okay, good day. We will be having a long discussion about the main engine lubrication oil system. Okay, so this diagram was taken from Kongsberg with Sulzer 12 RTA84 engine. Okay, so what is the purpose, or what are the purpose of lubrication in diesel engine? So the main purpose of lubrication in diesel engine is to reduce friction, and also it also cools down. By cooling, it also removes or absorbs some heat from the moving parts, so it also serves as a cooling, a sealing, and cleaning. So this is our sample engine, and we will be focusing on the lube oil system. So the oil passages, the one with the arrow, that is where the oil flows. Okay, so it goes from the inlet screen to the sucked by the pump, and through a uh, bypass valve, filter bypass valve. So it can go to the cooler, or it will go to the full flow filter. Then another differential pressure oil cooler bypass valve. So if it doesn't need any cooling, so it can go to bypass if it's still cold. And then it will go to the oil pressure regulator valve. It will regulate the pressure entering into the system, so to the crankshaft, into the governor, here to the blowers, to the oil main gallery, to the turbocharger, to the cam, to the crankshaft, to the piston cooling also, and to the bypass filter going back to the sump. Okay, so this is the inlet screen. So we cannot. Okay, so we'll continue. Okay, so this is the inlet screen. So the oil enters in the screen, and then here we have a pump. So this is a I think this is a screw pump. This one, a screw pump. This is the one that will be delivering the oil inside the engine. So we have a lubricating oil filter. So the filter is a duplex type filter. So if ever the one with the running filter is dirty, so you can change over to the clean filter, and then you can clean the dirty filter even when the engine is still running. Okay, so this is a duplex filter. So if this one will be dirty, you can use the other one, and then you can clean the dirty one. Okay. So we can also bypass the filter if we want. So in case of malfunction of filter, may be shut off by using the cock, or we can also use both filters. We can use the left filter, the right filter, or both. And also some engines do have centrifugal lube oil filter. So the pressure, the oil pressure will be the one that will help to rotate this filter, and then while the filter is rotating, so the dirty one will the dirt will be stuck on the side since it is rotating. So uh, the dirt will be stuck in here on this side, while the clean oil goes into this hole, that nozzle, and when it goes through this nozzle, it also pushes this filter or filter to rotate. So that's it. So here are the parts. So yeah, so its principle is from the pump it goes to the full flow filter and to the parts of the engine, and some part of the oil is bypassed. 10% of the flow is by going to the bypass flow, going to the centrifugal filter for cleaning. So it is cleaning as long as the pump is running. Okay, but we do still have lube oil purifier running running 24 hours in the purifier room. Okay, so here dirty oil goes inside to the center, occupying this space, the red one, and then it goes through here and then through the nozzle. When the oil goes out from the nozzle, it will help the centrifugal filter to rotate, and then the dirt or impurities will be stuck in the side of the housing, or in the what's they call this, the rotor out unit. Yeah. So never dismantle more than one centrifugal filter at a time. So the centrifugal filter should be cleaned once a month, checked for excessive vibrations once a week, and sludge buildup of sludge level maximum 15 millimeter before cleaning. So in this picture, we can see that this is the crankshaft, and in the center of the crankshaft there is a hole inside here. So this is where oil goes through, going here to the to this side, and then going to the center, going into this connecting rod or crank pin, lubricating the crank pin. Here also lubricating the main bearings, lubricating this part and this part. This is the flywheel, and this is the vibration damper, lubricating also the vibration damper. Yeah. And here we have a cooler. So the cooler is one that absorbs the heat taken from the engine by the oil. So here is how the oil flows. So it is sucked from the sump tank, going through a filter and through a pump, and this pump will push or deliver the oil into the main bearing, into the cam. So we have cam for the rocker arms, and cam for the fuel valve, going also to the oil filters and to the chain drive or belt drive or gear drive part of the engine, and all the moving parts, also to the governor for some engines, and to the turbocharger for some engines also. Okay, so this is our crankshaft, and then there are holes in which oil can enter. So from crankshaft to the bearing, main bearing, to the cylinder, or to the oil rail, to the camshaft, and here to the piston connecting rod, and to the piston cooling also. So this one, and also to the connecting rod, this one, connecting rod, going to the piston and going back to the sump or crankcase. So cylinder lubrication, so we have here we have a lubricator drilling here in this part, and then in this part there will be cylinder lubricator that will inject oil into the liner and piston. So this is an automatic lubricator. This is an automatic, so it has different multiple injectors that it will inject oil all around the piston and line, or all around the liner, so that the piston can move better. Here another example. So here are multiple points. So this is a little bit of an electronic type programmable distributor. So you can reprogram the distribution of oil, so depending on the load. So if it is in slow speed, so you can lessen the oil, while if it's at high speed or full load, or the engine is in full load, so more oil is used for lubrication of the piston and liner. So this is like a common rail or something, cylinder lubricator. So we have also alpha lubricator. So depending on the load, it adjusts its lube oil production, or so this is the main lube oil system. So from the oil sump, it goes to from the engine, or from the crankcase, or from the oil pan, it goes down to the oil sump. So the oil sump is not part really of the engine, it is below the engine. So it goes down to the oil sump, and then after that, the oil will be stocked by a priming pump going to a three-way valve, or a three-way valve, a thermostatic three-way valve. So if it needs cooling, so it will go to the oil cooler, but if it is still cold, so it doesn't need cooling, so it will bypass, going to the oil filter, and then entering into the engine. So after the engine, it will go back also again to the oil sump, and then if the main pump will be running, since priming pump will run, is used only during startup. So if there is another main pump, if the main pump will be running, this is a bigger pump, so it will supply 10% of its supply will go to a centrifugal filter for cleaning, while 90% of it will go to the engine. So if the temperature of the oil goes up as the engine starts, is running, as the engine is running, so the temperature of oil goes up. So to prevent it from to prevent its viscosity from decreasing, so some of the oil, or maybe all of the oil, depending on the temperature, will go to the oil cooler before entering into back to the engine. That one. Okay, so what are the daily inspections? So sump oil level. So you should check always the oil level in the sump tank. And then electrically measured temperatures and pressure in the lube oil system. So check the electronically measured temperatures, and also temperatures and pressures, and also the local or the manual or the Borden tubes temperatures and pressure gauges, and all thermometers and manometers. So these are the manual ones. So taking samples, the following data are important. So if you want to take samples of your lube oil and then test it and send it ashore for testing. So these are the important information that must be um, taken also. So installation name, engine number, engine operating hour, the number of hours the oil has been used, where the sample was taken, the oil brand and type, and the type of fuel used. So these are important information so that we can so that the shore or the testing facility can check properly how's the how's your oil, if it's still good or not. Okay, so what are the primary purpose of lubrication is to keep a clean layer of lubricating oil film or lube oil film between the contacting surfaces of the running parts or moving components in order to prevent friction, heat, and metal to metal wear or abrasive wear. So the secondary purpose of lubrication, so cooling. So in passing through the engine part, the heat is absorbed or picked up by the circulating oil. Therefore, it is made to pass through the cooler before being recirculated. Next is neutralization of acid products of combustion, especially for sulfuric acid. So since our engine in the since our piston has cooling has cylinder lubrication. So since we have cylinder lubrication, the other purpose of cylinder lubrication is to neutralize the acid products of its combustion. Since sulfuric acid and vanadium can cause damage to the piston head and the liner. Next is cleaning. So the washing away of wear, detritus due to surface rubbing or friction. Therefore, the oil is filtered and centrifuged. So oil also cleanses hot moving parts from carbonaceous deposits. And lastly, for sealing. So this is the case with the piston liner, where the oil provides a gas seal as well as lubrication. So since the on the top of the piston head, there's combustion, and to prevent combustion from going down to the crankcase, so oil also serves as a seal as well as lubrication in the cylinder or the piston. Next is the prevention from corrosion. So hot corrosion is caused by vanadium in the combustion chamber, and cold corrosion is caused by sulfur. So to prevent from corrosion, so as we can see in the 2.2 neutralization of acid, so if it neutralizes the acid, it also prevents the corrosion in the piston part or the combustion part of the engine up to the exhaust valves, to the turbocharger, and up to the funnel. So requirements, what are the requirements for a trouble-free engine operation? So first is the type of lubricating oil recommended by the manufacturer must be used. So never use an oil that is not recommended by the manufacturer because it may cause damage to the engine. Next is the lubricant to be supplied in proper quantities and at the right temperature. So over-supplying lube oil can be detrimental to the engine operation, and the right temperature also, or too low oil can cause damage also. So and then the right temperature, so if the temperature is not correct, if it's too cold, so it will not directly go into the engine. It will take time, and if it's too hot also, so the lubrication properties will be too thin to protect the metal to metal contact or abrasion. So provisions must be made to remove any impurities entering the system. So we do have a filter, and then if it's possible, clean the filter if at all times or if necessary. So So what are the different divisions of lubricating system? We have the external or the internal division or engine part of the system. So part of the internal division are the passages and ducts and piping, the crankshaft, what's inside the engine, the piston, the camshaft, the bearings, and everything that inside the engine. That's the internal division. While so this one, the crankshaft, this one, the connecting rod. So these are the holes in which oil will enter or penetrate. In the camshaft or in the rocker arm, in the rocker arm, in the rocker arm, in the push rod also, in the piston, so in the piston pin, in the piston under the piston crown also for cooling. So that's those are the internal division or engine part, internal lubricating system part, engine part. And we also have the external part of the system, which are the sump, the pumps, the coolers, the strainers, the filters, and the purifier. So this system is of pressure type or forced lubrication type, like this one. So everything that is outside the engine, those are the external part of the lubrication system. The wet oil sump, the suction pipe for oil. So those are the external part of the system. Okay, so lubricating system in large marine diesel engines of crosshead construction. So we have two types of lubricating systems for two-stroke engine or for crosshead construction. So first, we have a total loss system or feeding the cylinder. So these are the cylinder lubrication. So the oil in here will be consumed or will be used to lubricate the piston and liner, and then it also is used to prevent corrosion in the combustion, especially for sulfur and vanadium. Since our fuel has sulfur and vanadium, so to prevent corrosion, high temperature corrosion and low temperature corrosion, so we also use the cylinder lubrication in that way. So it is also used in feeding the cylinder, so it will be lost during combustion also. And the next part is the circulating system, or it is the one that's lubricating the running gear, the crankshaft, the camshaft, the piston head, the connecting rod, and all other moving parts. So it is circulating system since it goes back to the sump, and then you can reuse it. Okay, so description of a lubrication procedure. So the lube oil pressure pumps draw the oil from the drain tank, lube oil tank, or pan, or sump through the suction strainer. So the drain tank is fitted with a level gauge. So the pumps discharge oil through fine filters to the cooler. The discharge pressure ensures that there will be no leakage of salt water or cooling water into the oil in the event of faulty cooler. So lube oil thermostatic valve mounted on the cooler regulates the oil temperature flow of either the lubricating oil or the cooling water. So regulating valves control the oil distribution and its pressure in all moving components, and pressure gauges are fitted before and after the filters so that you can check if the filter is still clean or dirty. And then the system is fitted with a number of alarms. So pressure loss alarm, oil level alarm in drain tank, temperature alarm, pressure relief valves, usually mounted at pump discharge. So these are protections for the system. Then oil should be permanently purified at sea. It may be also heated to assist purification. So even at port, oil is still, the purifier is still running. Okay. So these are the two. Okay. This is the lubricating oil system for Sulzer. We have the This one is the recirculating system, and this one is for the, what we call that, what's that name? We have the total loss and the circulating system. Yeah. So this is the circulating system, and this is the total loss system, since oil here will be used also for combustion, during combustion. Okay, so this is a Sulzer engine. So we have here the charge air cooler. We have here the lube oil cooler, charge air cooler, lube oil cooler. The lube oil thermostatic valve is in here. The lube oil filters are in here. The low temperature thermostatic valve is here. The lube oil, so it's not that clear. Pre-lubricating pumps. The main lube oil pumps. LT pump and HT pump. So the pumps here are attached to the engine. Then lube oil pressure controller. Okay, centrifugal oil filters. We have two centrifugal filters, so both are used, but you can clean one by one. Do not clean it both at the same time. So this is a lubrication oil system for Sulzer. So in general, the oil pressure which is necessary for the main bearing lubrication is raised by the main lube oil pump. So these are the main lube oil pumps. And for the crosshead bearing is raised by the crosshead lube oil pumps in here. So the main bearing and crosshead bearing lube oil systems are interconnected through a non-return valve. So there is a non-return valve in here. So the main bearing oil is also used via an articulated lever to cool the working piston crown. So parameters. So the normal operating pressure for our main bearing is 3.4 to 4.2 bars. So since lube oil is very important, and loss of lube oil will damage the engine. So the main bearing should always have a pressure of more than 3.4 bars to have positive pressure and to be sure that the main bearing is lubricated. The crosshead bearing has a higher pressure requirement since it is above the engine. So crosshead bearing normal operating pressure is 10 to 12 bars. And for protection, we have slow down parameters. So if, for example, for the main lube oil pressure, if it goes below, since our normal operating pressure is 3.4, if it goes down to 3.2 bar, so the main lube oil pressure slow down alarm will be activated and the engine will go slow down. So it is a protection. For the crosshead lube oil pressure, if it goes down to 9 bars, so automatic the engine will slow down. For main engine piston lube oil outlet temperature, if it reaches to 85 degrees Celsius, so it is very hot already for a lube oil or for our lubrication, so it will send a slow down. The engine will slow down at this moment. So for main engine lube oil inlet temperature, so this is the lube oil inlet temperature at 55 degrees Celsius. So it is inlet to the engine. So 55 degrees Celsius, then it will trigger a slowdown for the engine. For the thrust bearing, if the temperature reaches to 65 degrees Celsius, outlet temperature, thrust bearing outlet, so the engine will slow down. And then for oil mist detection, up to 60%. If it goes to 60% high, the oil mist inside the crankcase is 60% high, then there will be slowdown. Turbocharger bearing lube oil temperature, if it reaches 120 degrees Celsius, so there will be slowdown. main engine cylinder oil flow low. So if the cylinder oil flow is goes down to 0.34 kilograms per hour, so it will trigger slowdown for the engine. While we also have shutdown parameters, so this is a protection to prevent damage of the engine, so it will shut down the engine in case these parameters will be reached. So main lube oil pressure, if it goes down to 3 bars, so since our operating temperature is minimum 3.4, so if it goes down to 3 bars, so the main engine will shut down. If the cooling water pressure is less, this is for the cooling water, so it is not related to lube oil. If the main engine piston lube oil flow goes to 2 kilogram per second or moves up, so if the piston lube oil is too much flow, so there might be a problem, so there will be shutdown of the engine. Okay, so the main engine lubrication oil system in general, should the crosshead pump fail, so the crosshead bearings will be supplied from the main bearing oil system to the non-return valve. So for example, if here this is the non-return valve, so if the main lube oil is giving supply to the engine and also giving supply to the crosshead, but if this crosshead pumps will fail, so we can use this valve, so we can close, or this valve will automatically supply pressure into the crosshead if ever the crosshead pumps fail. So main engine can only be operated at low load under such conditions. So if we use this part of the flow and the crosshead pumps is will fail, so engine will just operate in low load or in slow down. So the crosshead bearing oil is further used for exhaust valve spindle lubrication. So for our exhaust valve spindle for lubrication and drive for the cylinder lubricator, so the crosshead pumps or crosshead bearing oil is also used. Okay, so the oil for exhaust valve actuator pumps passes from the crosshead bearing oil system through an air purifier. So for actuating the exhaust valves, the oil pressure is raised by the actuator pumps to about 160 bars. So that's strong. So the lubrication oil from the main engine sump is collected in a service tank below the engine. So it will go down here in the service tank or a sump tank below the engine. So it is not really part of the engine. Okay. And then the lube oil pumps are protected by a pressure relief valve in here, which opens for pressure over a preset value. So if there are overpressure, so there is a protection, so to prevent damage to the pump and to its motor. So the service tank oil can also be cleaned in a lube oil purifier here. So we can open this one, inlet, suction and discharge of the lube oil purifier. So it is continuous purification 24 hours. So a makeup pump enters new oil with flow directly to the service tank. So if the service tank level goes down, so we can turn on this makeup pump to make more to give more oil to the service tank. Okay, the lubrication oil is cooled into low temperature fresh water cooled lube oil coolers and is then passing a double filter, passing here to a double filter. We have the backflush filter as the main, and if there will be a problem in the backflush filter for maintenance, so we can use the bypass filter. So the lube oil temperature is controlled by a PI controller which regulates a bypass valve for the lube oil cooler. So if it doesn't need cooling, so it will go to bypass, and if it needs cooling, it will go to the cooler. So the lube oil filter must be cleaned regularly to avoid pressure flow reduction, or to avoid pressure reduction or flow reduction. So usually this will be cleaned every arrival at port if the engine is stopped. Or you can still clean it. If this one is running, you can clean the standby filter. So for cylinder lubrication, the cylinder day tank has a volume of 4 cubic meters. and there is a cylinder lube oil make-up pump to refill the day tank. The make-up pump takes suction from the cylinder lube oil storage tank. So at low cylinder lube oil tank level, there will be main engine slow down or shut down. So always fill the cylinder lube oil tank level. It is possible to adjust each cylinder lubricator individually from the individual cylinder screen. So our lubricators are programmable, so it can be adjusted individually. So start up for the main engine. So ensure that main engine sump has sufficient oil. So these are the operation procedures in starting up for main engine. So first, ensure that main engine sump has sufficient oil. Check the oil level. Set temperature controller to 45 degrees auto. Ensure that suction and delivery valves, all the valves, suction and delivery valves on both main lube oil pumps are open. And ensure that one cooler's inlet and outlet valves open. Ensure that inlet and outlet valves to backflush filter are open. So only this one is open. Ensure that main bearing supply valve is open. This one, main bearing supply valve. So start up for main engine. So start one of the main lube oil pumps in manual. Wait until the lube oil pressure is risen to about 3 bar. Then set pump control to auto in pump or compressor auto chief page. So it should only be necessary for one pump to be running with the other in standby. Ensure that oil is flowing to main bearings and piston cooling at correct temperature. So we have sight glass in here, so we can check if the oil is going to the piston cooling, and check the pressure for if the oil is going to the main bearings. So start up crosshead lube oil supply. So after starting the main lube oil pump, you can start up the crosshead lube oil supply. One pump started manually after opening valves, then switch to auto when the pressure reaches about 8 bars. So start up for cylinder lube oil system. Here, cylinder lube oil system. So ensure as a minimum 0.5 cubic meter in the cylinder oil day tank. So check that oil relevant valves are open. The flow will vary with engine speed. So the lubricators will run automatically as the engine starts. So there is also a practice that you should activate this manually before starting the engine to be sure that there are oil in the piston and liner. So that's for starting. And for normal stop procedure, so when engine has stopped at finished with engines, wait for approximately 30 minutes. So in this engine, the manufacturer wants 30 minutes cool down to ensure that engine has cooled down and stop all before stopping the lube oil pumps. So some temperature in port is normally maintained by continually running the lube oil purifier. So note, before starting main engine, always check the main and the crosshead lube oil pressure. So that it is very important to have a proper pressure for the main and the crosshead before starting the engine. Okay, so we have the main engine bearing system. So we have here 1, 2, 3, 4, 5. Since this is a 12-cylinder engine, so we usually have 13 main bearings. We have here the oil mist. Okay, so the bearing temperature shown are the crosshead bearing. We have here the crosshead. Bearing. So crosshead bearings. The crank pin in here. The crank pin. This one. So crank pin bearings. We have the main bearings. This one. 1, 2, 3, 4, 5, up to 13 main bearings, and the thrust bearing in this one. So we have here a temperature for thrust bearing, and we have here a pressure. So comparison between the various bearings can be easily made, and should a bearing temperature increase above 90 degrees, then the indicating bar will change to red to aid identification. At the same time, the bearing concerned will also change color to red. So the screen will also display the presence of oil mist within the crankcase, as well as which units are affected. Should oil mist be detected, then the engine protection system will activate and engine slowdown will occur. So what should we do if there will be oil mist alarm? So what are the procedures for reaction or procedures to do when there is oil mist alarm? First is slow down. So reduce engine power or pitch down to slow down level if this is not an automatic function. So this will drastically reduce the load on the engine bearings and hence the production of oil mist. Number 2 is contact bridge. So and ask to stop engine. So the engineer should not stop the engine because we don't know if there are traffic in the sea. So traffic in the vessels. So if the vessel is in a confined area, if it may not be possible to stop the vessel, hence the engine will continue on minimal power. So the captain will change course depending. So the captain may be going to change course so that they will go to a place in which they can stop the engine. Okay, so when the stop order is received, stop the engine and close the fuel supply to the engine by stopping the booster pump. So close the fuel supply to prevent combustion that may also cause oil mist, or the combustion may go into the crankcase or something. Okay, next is number 4, switch off the auxiliary blowers. So to prevent the oil mist or to prevent crankcase explosion, so we should turn off first we have turned off the fuel supply. Next we have to turn off the air supply, the auxiliary blowers, and then if possible open engine room casing. This will reduce the pressure rise in the engine room should the crankcase relief devices operate. Next is vacate. Personnel to vacate engine room. This is for the personal safety of the engine room staff should flames issue from the relief valves. So it may be prudent to have a minimal staff in the control room to monitor the situation and to maintain the main services. But under no circumstances should personnel operate on the engine. Next is prepare for firefighting equipment. So a safety precaution against outbreaks of fire in the engine room from any flames issuing from the crankcase relief doors. So just prepare the firefighting equipment. So do not open the crankcase until after at least 20 minutes. So let it cool down first. You must allow time for the oil mist to cool and fully condense. So it is also recommended that the oil mist detector alarm level should reset, which indicates that the oil mist levels are well below the lower explosive limit. So wait at least 20 minutes, but if the oil mist detector alarm is still active, so do not open the crankcase. So let it reset first, or let it become normal first before going or opening the crankcase. So which indicates that the oil mist levels are well below the. So obviously no naked flame should be used on the initial entry. So don't do this at home. Don't do this picture. Next, stop oil lube oil pumps to allow personal entry into the crankcase. So if the crankcase door is now open, so stop oil lube oil pumps so that you can now enter the crankcase for inspection. So isolate the starting air and engage the turning gear. So you put it here, engage the turning gear. So to prevent any starting of the engine. And number 11 is open the crankcase doors and inspect the following areas for overheating. So check the main and bottom end bearings, thrust bearing, crosshead bearings, piston rods, stuffing boxes, the gears, the vibration dampers, moment compensators, the articulated pipes. Check for any cracked piston crown, allowing oil mist to enter crankcase via cooling oil return, and overheated diaphragm from a scavenge fire. So all check everything. So check check everything so that we can monitor, or we will know where this oil mist alarm came from. Where did this oil mist alarm came from? So overheating can be identified by this one. We have melted or squeezed white metal from the bearings, discoloration of the crankcase paint in the vicinity, burnt or carbonized oil deposits, excessive bearing clearances, excessive oil flow from a bearing. So these are identification that the engine is, there is an overheating that causes the oil mist. Okay. So that's it. So this is the main engine lubrication oil system. So I hope you have learned many things on our video today, and please share, subscribe on our channel, and see you on the next video. Thank you.